So what we want to do here is use a process called completing the square to rewrite this quadratic polynomial. And what that means is I want to take this and I want to rewrite it so that it looks like this. Right? So that it looks like a linear factor squared plus a constant. And this is really a really important tool to have in your toolbox. It shows up all sorts of places. You can use it to solve quadratic equations. It's used to derive the quadratic formula. You can use it to find the vertex of a parabola, right? The graph of a quadratic equation. And it shows up all over the place when you're talking about conic sections, like circles, hyperbolas, parabolas, that sort of shape. All right, so I don't want to lose track of this, so I'm just going to move it out of the way here. And I'm going to start with our original polynomial. Right now, the key step in this process is adding a number that is going to make that x squared plus 5x part a perfect square. Right? So how do we know what that number is? There's a little formula we're going to use. You take the b value, you take the number in front of the x, divide it by 2, and square it. That's the number that I need to add to make that x squared plus 5x a perfect square. So if I do that, I get something like this, but that's not okay. I can't just arbitrarily add numbers to the expression. That changes it. Right? So what I have to do to balance that out is I'm also going to subtract 25 fourths. Right? Because now I've added 25 fourths and subtracted 25 fourths. Well, that's 0. And adding 0 to the equation is fine. To the expression is fine. That doesn't make any changes to it. All right, so now our next step, this is where it gets a little interesting. My claim here is that x squared plus 5x plus 25 fourths is a perfect square. That I can write it like x plus a squared in my original polynomial there. And it may not be immediately obvious to you how to do that, because when you learn to factor polynomials, that constant term is always an integer. Right? It's never a fraction like 25 fourths. Well, fortunately, there's a really quick and easy way you can get to this. The factored version of that is this: x plus 5 halves squared. Look back over at the number we squared there, right, to find the number that we added. You notice it was 5 halves. That's not a coincidence. That is always going to be the case. So if you're ever not sure how to get to that factored part, it's just that number over there. It's the original b value divided by 2. Okay, so now all that's left is to simplify that. 3 minus 25 fourths. 3 is 12 fourths. Do a common denominator. 12 fourths minus 25 fourths is negative 13 fourths. Now, I'm going to take that x plus a squared thing that I kind of set off to the side. I'm going to bring it back down here. You notice that, yeah, I did exactly what I wanted to do. Specifically, a ended up being 5 halves. B ended up being negative 13 fourths. So if you like this presentation, please don't forget to click on the like button down at the bottom here. And I've got some links here for you. One to another lecture where I derive where that 5 halves number came from. If you're interested in kind of seeing the reasoning behind why that works. And there's another link here to another video on completing the square that's a little more complicated situation. It's one where there is a number out there in front of that x squared term.